What's up, everyone? I hope everybody is doing well, and we are going to continue and chapter 9, the respiratory system, part 2. So we have stopped at the development of the respiratory system. The developing human undergoes a remarkable transformation from a single cell to an individual with nearly complete set of organ systems. Please forgive me if I make any mistakes. I am learning here just the same way you are learning. And if I make a mistake or that I went over something that you did not understand, please comment below and make it clear for me so I can fix or adjust my mistake. So let's continue. Development of the respiratory system. Development of the respiratory system. This part will be the following part that we're going to be reading is how does the respiratory system develop inside the womb, and how does it start. So let's start by reading. The developing human undergoes a remarkable transformation from a single cell to an individual with nearly complete set of organ systems. So human body starts with a cell. This is a cell we all know from biology. It has a nucleus and all the other organelles inside the cell, right? So a human being starts from a single cell, from one cell, and then they have systems, which is example like the respiratory system, the urinary system, the endocrine system, all other systems until to create a human body. This is all in biology. I'm not going into detail with biology. I'm going to stay focused on the development of just the respiratory system. So the developing human undergoes a remarkable transformation from a single cell to an individual with nearly complete set of organ systems. The development phase of fertilized egg are divided into embryonic and fetal periods. So we have two periods. We have embryonic and then we have fetal period. So we have two sets of periods during development. So the developmental phase of fertilized egg are divided into embryonic and fetal periods. The embryonic period occurs during the first 8 weeks of pregnancy. So this period of life, it occurs during the first 8 weeks of pregnancy. Correct? So the first 8 weeks of pregnancy is called the embryonic period. I'm gonna put called embryonic period. Okay, so the embryonic period, right, in the first 8 weeks of pregnancy. During this period, the organ continue to develop and refine their structure. Oh, I'm sorry, I skipped one sentence. The fetal period occurs during the remaining 32 weeks of pregnancy. So we'll go to this period here. So we have 8 weeks of pregnancy, which is the first 8 weeks of pregnancy is called an embryonic period. So the second fetal period, 32 weeks. So we have the 32 weeks remaining of, so after these 8 weeks remaining, we can put remaining 32 weeks of pregnancy is called fetal period. Okay. So we understand that a woman gets pregnant for about 40 weeks. So we can put here 42 weeks. 42 weeks, okay? Or 40 weeks. Anyway, we are focused here not on the weeks or any whatever. We're just gonna keep going and focus on the development of the respiratory system. Okay, during this period, the organs continue to develop and refine their structure and function. So in those periods, those organs that are developed are like respiratory system and all other organs. Let's keep continuing. The respiratory system develops during this period as a fluid-filled structure playing no role in gas exchange yet. Must be developed efficiently to assume this crucial activity at the time of birth. This is very important. So that means in your mom's belly, during these two periods, the respiratory system developed these periods as a fluid-filled structure. Fluid-filled structure playing no role in gas exchange. You must develop efficiently to assume this crucial activity at the time of birth. So this means, and I'm gonna put a separate note here, or I can put it here and put a star next to it so I can understand it. In your mom's belly, your lungs are still fluid-filled structures and they play no role in gas exchange. That means there's no oxygen going into your lung like when you're talking right now or as of now. Now what's inside your lungs is air. Air, and gas exchange happens through air going into your lungs, and then it matches with blood. So gas exchange can happen. So at this point inside your mom's belly, your lungs are filled with fluid. Correct. Okay. Now we can get a question out of here. We can say, let's just continue because it'll be too much. So, yet must be developed efficiently to assume the crucial line. Okay. Its development is a continuous process that begins in the early stages of embryonic period and extends for years after birth. The embryo is made up of 3 distinct germinal tissue layers that ultimately form all tissues and organs: endoderm, mesoderm, and ectoderm. From these layers, the organ systems will arise. So the respiratory system comes from these 3 layers of derms: endoderm, mesoderm, and ectoderm. And remember, after birth, your lungs are still developing. As you can see here where they say embryo is made up of distinct, the embryonic period extends for years after birth. Its development is a continuous process that begins in the early stages of embryonic period and extends for years after birth. So, respiratory system develops in the embryonic. So we could put starts to develop in the embryo, where did they say? The embryonic, right? Period. And it extends for years after birth. So after birth, your lungs are still developing. They say to many years after birth. We don't know how many years, but we will find out later. The development of the respiratory system has characterized into various stages. So we have different stages of respiratory system development. It shows that various stages of the lung development. So there are sending us to figure 9.1. So we have to go to figure 9.1 to see the stages. So let's continue so that way. Okay, shows the various stages of the lung development. And table 2.9.2 summarizes the major development of events in each phase. Respiratory development begins in the embryonic period on the approximately day 22 after fertilization. A primitive laryngeotracheal tube forms from the groove in the fourth pharyngeal pouch. From the groove tracheal bud forms by the end of the fourth week of life, figure 9.2. During week 5 of development, the tracheal bud continues to develop and bifurcates, splits into left and right primary bronchial buds. Okay. Okay. So this is table 9.1. Structures arising from the 3 germ layers. So we know that endoderm, mesoderm, and ectoderm. So in the endoderm, we get a respiratory tract, digestive tract, bladder and thyroid, and liver and pancreas. So those come from this endoderm. And this here, you can read it, and those are just the structures where they occur. But when you look over here, as you can see, the major phases of respiratory system. Embryonic period is up to the 8 week that we talked about, 8 weeks. And then development of the respiratory system continues all the way up to 8 years. I feel like we did that already because I have writing here. Anyway, let's continue. Now let's continue reading here so we can understand. Injuring to the embryo or genetic dysregulation during this crucial phase of development can lead to many congenital anomalies, including tracheoesophageal fistula, tracheoesophageal fistula. What this means is you have the esophagus right behind the trachea that has rings. This is the trachea. This is where the air goes into your lung. Those are 2 lungs. Air goes through here, and this is right here behind your trachea is the esophagus. This is where the food goes into your stomach. Right over here, this is your stomach. Those are your lungs. This is the trachea. Tracheoesophageal fistula. That means there's a hole here between the air and the food. And when there's a hole between them, this is called tracheoesophageal fistula. Could be a problem because food when you swallow food, can go into your lungs instead of going to your stomach. And that's a big problem that has to be fixed medically. And this occurs sometimes if you put the ET tube, endotracheal tube, and you create a tight seal here, you inflate the cuff too much and you leave it for a long period of time, it's possibly that it could damage your trachea, and you can develop tracheoesophageal fistula because you're cutting the blood supplies to this area, and that can affect the trachea and the esophagus. So here they're saying during development of the embryonic period, if there's any trauma or injury to the fetal during that stage, it can cause this. Also, it can cause esophageal atresia, corneal atresia, pulmonary hypoplasia, and complex heart and vascular. And I'm going to discuss later. The main point is any trauma can cause any other problems during that period. At approximately 6 weeks of development during lung airway growth has the appearance of glandular structure, hence the name of the second phase of development, the pseudoglandular stage. For the next 10 weeks, the growth and bronchiole of tracheal, bronchial tree, and pulmonary vasculature continue in climate with formation of terminal and respiratory bronchioles. The dysfunction between these two types of bronchioles is important. Terminal bronchioles are conducting airways only and do not participate in gas exchange with blood. Respiratory bronchioles have more superficial capillaries and are capable of gas exchange with blood, becoming more elaborate as development continues. So this paragraph, this whole page is basically about the structure, how the baby is developed of the respiratory system. This is anatomy and physiology. There's not a lot to explain, but to understand these words and to look at them and keep reading and pointing out main key points. So I'm going to continue to do the best that I can, and I hope I help you a lot. For the next 10 weeks, the growth and bronchiole of the bronchial tree and pulmonary vasculature continue in climate with formation of the terminal respiratory bronchioles. The distinction between these two types of bronchioles is important. Terminal bronchioles are conducting airways only and do not participate in gas exchange with blood. So you can write down terminal bronchioles. Make a point here so that way when you review before the test, you can understand. This can be, I can ask you true or false. I can say true or false, and I can put terminal, I can put bronchioles, terminal bronchioles, where we're at. I can put terminal bronchioles are types of, okay, conducting airways only, do not participate. Okay, I can put true or false. Terminal bronchioles participate in gas exchange. Then the answer will be false, because they do not participate in gas exchange. I feel like if I don't explain gas exchange, you will not understand what do they mean about gas exchange. So I'll explain gas exchange on this separate piece of paper right here. So your lungs, this is a lung, and this is your second lung, right? Then you have the trachea that goes here, right? And this goes here. That's a boxed lung. Anyway, it doesn't matter. So the air goes into your lung. Air goes into your lung. What happens here is gas exchange at this point here. What that means is you have an alveoli, which looks just like that. This here, but it's very tiny, you cannot see it only in a microscope. But this is the alveoli, and this is a balloon. This is almost like a balloon where the air goes. This is the alveoli, and then you have capillaries, which is small. You have, it's like veins, but they're very small, like the ones that you see here, but you cannot see them, only under a microscope is capillaries. And those capillaries where they take the blood. All right, so blood comes through the capillaries. So this is a red blood cell, and that's a red blood cell, and this is a red blood cell, and this is a red blood cell. The air goes into your alveoli, air, and due to the pressure or force, but we will get to that in mechanical ventilation and the ventilation chapter, it pushes the oxygen to your blood, and then the CO2 goes out. So oxygen, O2, goes into the bloodstream and CO2 goes out. This here is called the gas exchange. Correct? So terminal bronchioles are here. This is the trachea. This is the main stem bronchioles. This is the main stem bronchiole, is the right side, and then this is the left side. The terminal bronchioles are up here. They're still hollow tubes. They are just tubes. And when there's no alveoli, this is the alveoli, there will be no gas exchange. So gas exchange only happens in the alveoli. The terminal bronchioles are over here. They're not here. This is the trachea and the main stem bronchi and the other bronchi. Okay, so the terminal bronchioles are down over here. Okay, so keep that in mind. So let's continue. Terminal bronchioles are conducting airways only and do not participate in gas exchange with blood. You see that? The respiratory bronchioles have more superficial capillaries and are capable of gas exchange with blood, becoming more elaborate as development continues. Branching and dividing of the tracheobronchial tree occurs in several ways as the result of different gene expression. In the epithelial lining of the airway beginning to differentiate into pulmonary epithelial, and the proximal airway differentiates into cuboidal epithelial in the more distal bronchioles. Figure 9 to 4. I'm just going to continue so we can move on to something else. Development of the cilia, mucus glands, and goblet cells occur at the time in lining most of conducting airways. Beginning with the tracheal and moving distally, the amount of cells in the middle layers of the airway increases. Okay, let's start from the beginning. Beginning with the tracheal and moving distally, the amount of cartilage supporting the airway decreases as smooth muscle cells in the middle layer of the airway increases. Altered development of smooth muscle cartilage and vascular structure can lead to other congenital pulmonary disorders such as tracheomalacia and enemas pulmonary arteries, causing the vasculature rings to pinch the airway. Let me check if I'm recording, because last time I was recording for a whole hour and it was not recording. Okay, it's recording. The Canelo stage begins at week 16. So this is what they're talking about. They just explained this stage here and what happens. Now they're here and they're gonna explain what happens in this stage here. The canalicular stage begins at week 16 and continues until week 26. Okay. The canalicular stage overlaps with the pseudoglandular stage because the superior region are developing slightly faster than the inferior region. During this phase, primary changes include the development of 2 to 4 more generations of respiratory bronchioles from each terminal bronchiole. In the last several weeks of this stage, the region beyond each terminal bronchiole forms the function structure called the acinus. So the acinus, those are structures, that's where they do have here all the stages and what happens. Okay, let's just continue. The basic gas exchange unit of the lung. So now you see the acinus is right below the terminal bronchioles, so that's where gas exchange occurs. At this time, the two principal epithelial cells types that cover the gas exchange surface begin to appear. Type 1 and type 2 pneumocytes. At the end of the Canelo period, 24 to 26 of gas exchange, the fetus is born, is capable of sufficient gas exchange and available if supported with supplemental oxygen ventilation support and surfactant administration. This is very important here. So they say 24 to 26 weeks of gestation if the fetus is born. So if the fetus is not fully developed, it means if the woman was only pregnant for 24 to 26 weeks, 24 to 26 weeks, the baby can survive as they were born here because their respiratory system is capable of sufficient gas exchange. That means at this age, how can they be supported to live? Using oxygen, ventilation, and surfactant administration. So, if the baby was born at 26 weeks, they can survive. And how can they survive? We can give them supplemental oxygen with ventilating them and also administering surfactant. And you will see that in neonatal, in your respiratory clinicals. You will see that done because you will see post pregnancies. I think that's the wrong word that I used, but premature. That's the one I'm looking. Premature babies, you will see. Infants, you will see premature. And they were born premature, therefore they need oxygen, ventilation, and surfactants. So here what they're saying is before the 24 weeks, the respiratory system is not capable of gas exchange. And this is what we wrote down here. Gas exchange here. This is how important it is. So if the baby is born before the 24, so if they ask you a question, if the baby is born in the Canelo stage, can they survive? And the answer is yes. So that is another question, another test question that you can look out for. You can say, they can ask you if the baby was born in this stage, can they survive? And the answer is yes. Okay, and it's 24 to 26 weeks. And the main reason is why they can survive is because they are capable, they can have gas exchange. But they do need support, such as mechanical ventilation, oxygen, and surfactant. Now let's keep on moving. During the terminal secular stage, more terminal bronchioles and their associated acinus form and develop from 26 weeks to birth. The formation of the total number of terminal bronchioles is completed at the end of this phase. The cuboidal epithelium that line the blind tubules of the acinus continues to differentiate into rounded secretory cells, type 2 pneumocytes, and flatter squamous epithelial cells, type 1 pneumocytes. Capillaries continue to form near and plunge from the surface of the acinus, although some type 2 pneumocytes form by 20 weeks of gestation. They are in such small numbers and of such primitive function that their impact on lung function is marginal. From this point until birth, there is rapid proliferation of the alveolar ducts and sacs formed from the respiratory bronchioles. Okay, so this here, table 9-2, is very important table because it breaks down all that we have read on this page here. So embryonic period, 22 days, 20 to 22 days, primary pharyngeal arch form, laryngeal for bud forms. So this is important that you need to understand. So 26 weeks, the laryngeal, that's trachea, that has to do with your respiratory system. Now, pseudo, glandular stage, canalicular stage. Okay, so, and then pseudo stage, this is all terminal bronchioles and associated pulmonary vessels form. So we know that terminal bronchioles develop at the pseudoglandular stage. And we say that terminal bronchioles, we cannot do gas exchange during this stage. No gas exchange, correct? And this is important. This will come on one of the tests. I remember when I was in school, this question is very important, and it is one of the most important questions. So if the baby was born during these stages, 16th week or 10th week or 6th week, they cannot survive because the respiratory system is not ready for gas exchange. In order for you to live, you need air that goes into your lung and goes out, which is gas exchange. We need blood and air to come in and match into the gas exchange so we can survive based on oxygen and other things. During the canalicular stage, if the baby is born during this stage, they are able to survive because they have an acinus that is begin to form, and this means where gas exchange happens. And acinus, I wish I can find one here, but it's part of the lung where the alveoli is. Okay, now type 1 and type 2 pneumocytes begin to appear and replicate. This is beautiful. So we have two types of cells in the lung that begins to appear, and that's where the gas exchange is going to occur. Pulmonary capillaries develop. There you go. Pulmonary capillaries develop at the surface of the acinus. Immature surfactant begins to appear in the lung. So when you have pulmonary capillaries, which is the vessels, the small capillaries, we cannot see them. They're very tiny. Let me see if they have a picture of the capillaries. They don't have it, but you understand. Should be known by now. If you are up to this point, you know what's capillaries mean. Anyway, so the pulmonary capillaries develop surfactant acidus and mature. So during this stage, the canalicular stage, infants will survive when they are born prematurely during the canalicular stage because the place where gas exchange can occur has been developed. Okay. Now, terminal saccular stage, that's another one. Till birth, terminal sacculars increase in number. Pulmonary cavities distinct proximity, type 2 pneumocytes. And all this is developing. Alveolar stage, this is when I was telling you the alveoli is that structure that look like just like this. That's where the air goes in. And those are the capillaries. Red blood cells goes through here. Gas goes in and gas goes out. That's gas exchange. Gas going in and out. Different types. The gases that are here there are 4 or 5 types and much more that goes about. We're just focusing on oxygen and CO2. And Also, surfactant is a very important. That's why they administer surfactant, because surfactant is very important. As you can see here, surfactant production increased because you need surfactant to keep this alveoli open. Because if it's not open, there will be no gas exchange. So periods after birth, okay, so first breath and lung fluid, cleared adult circulatory pattern established. So when the baby comes out for the first day, the fluid from the lung, remember when you are in your mom's belly, when the baby is in their mom's belly, it is still filled with fluid. When they first come out, the fluid goes away, flushes out, and then air takes the place of that fluid inside the lungs. And this is the chart they were referring us to look at, which is figure 2-1. Those are the layers, and this is what happens. And this is what I was telling you, the esophagus is right behind the trachea. So this will form into becoming a trachea. The esophagus right behind it. There's no space between them. That's when you intubate, sometimes intubate a patient, it goes into the esophagus if you did not see the epiglottis. And we're gonna move on. Okay, now let's move on and keep reading. The type 1 pneumocyte of the saccular walls thin and elongate to cover the walls of this region. Type 1 cell become the primary gas exchange cell in the lung with close approximation to developing pulmonary capillaries. Type 2 pneumocytes form and secrete the verb pulmonary surfactant that are necessary to alter surface tension and help keep the lungs inflated. This is very, very important, people. My respiratory people, this is important to understand. Oh, I just scratched it over. Anyway, so we have two types of cells, and we say they develop where? Canalicular stage. So we have type 1, and we have type 2. Okay, we have two types of cells. So type 1 become the primary gas exchange cell. So type 1 becomes exchange cell. Type 2 becomes the secretary. We could say type 2 becomes the cell that secretes pulmonary surfactant, because surfactant creates surface tension, and surface tension helps with keeping the lungs inflated. I will explain here. So what they're saying here is we have two types of cells that develop during that stage, type 1 and type 2. Type 1 is where gas exchange happens, right? Type 2 cell is what produces the surfactant to keep the lung inflated. Remember, your lung is The major part is the alveoli. This is the alveoli, right? This is the capillary that passes through here. This is the red blood cells. This is where gas exchange occur, correct? Oxygen goes in, CO2 goes out. CO2 and oxygen. There is a layer here, a thin fluid, which is the surfactant, that keeps the lung inflated. It keeps this alveoli open. If it's collapsed like this is a collapsed, and then the blood here, there will be no oxygen in here. It cannot go in or out to the blood, and we need the oxygen. So this must be open. This must be open. What helps keep it open is type 2 cells that are just placed here, and they secrete the surfactant. That's why when they are developed in this canacular stage at 24 or 26, there's not enough type 2 cells that can produce the surfactant to keep the baby's lung inflated. So they administer a surfactant that is manufactured for the baby to keep his lung open, because to create the surface tension. And this surface tension is what keeps the alveoli from collapsing, keeps it open. Because remember, your lung has to be filled with air. If it's not with air, if it's collapsed, there will be no gas exchange, there will be no surviving, you cannot survive. So this is very important to understand. So type 1 is what the alveoli becomes, and type 2 is what produces the surfactant. So we have to live with these two types of cells. We have to have them in our lung. Let's keep going. The development of the mature alveoli, accompanied by capillary proliferation with the walls, marks the final phase of lung development, is known as the alveolar period. Okay, so after the alveolar period, we understand that more alveoli develops, and then your lung is a lot of alveoli, millions of alveoli, and then you start to gas exchange and you survive. This phase begins at about 32 week of gestation and continue for years after birth. So that means continues until the age of 8, and then probably your lungs stop developing. This phase begins, okay. During this phase, the terminal saccular development hexagonal pouch-like region called alveoli within their walls, resulting in a greater number of alveoli that enlarge to a mature state over time. Rule of thumb is very interesting. The development of mature alveoli marks the final stage of the lung development. We understand the last stage is alveolar development, okay? Known as the alveolar period. This period begins approximately 30 weeks of gestation and continues for years after birth. As a result, premature infants younger than 32 weeks are at greater risk for developing respiratory distress. Okay. We have said that infants under 32 weeks can survive. We said from week 24 to 26 they can survive, because that cell is, but they still have respiratory distress. And respiratory distress means that they cannot breathe adequately, efficiently. They cannot breathe because they need either oxygen, or we need to ventilate them, or they need surfactant administration to keep their lungs open. Okay, so we can have some gas exchange so their oxygen can be up there. SpO2 can be high. We need to give them to their lungs. Okay, so this is very important. And here is a question they can ask you in this. They can ask you they can ask you about what is the final stage, or they can ask you why the patient is in, premature infants younger than 32 are at greater risk of developing respiratory distress. Why they are at risk? Because remember, their lung is not fully developed. They do not have the mature type 1 and type 2 cells that are producing, remember, type 2 that produces surfactant. I'm going to keep coming back to that. Now let's continue. A full-term newborn infant. Full-term no infant means full term. That means they reached the 42 or 40 weeks in their mom's belly. Newborn infant that approximately 50 million. Remember, they have about 50 million alveoli. This number continues to increase approximately to 2 to 3 years after birth. So you see how many grape-like structures, which is called alveoli in the lungs, about 50 million. The number, it could go to any. This is just an approximate. The alveoli are lined with type 1 and type 2 pneumocytes covering pulmonary capillaries forming below the basement membrane. Okay, those alveoli are covered with type 1 and type 2 pneumocytes. So those are the two types of cells that we talked about. Human pulmonary surfactant. Remember the pulmonary surfactant that we talked about that is produced by type 2 cell? You see, it keeps coming back. That is important. Which promotes lung inflation. Lung inflation, which means just keeps the lung open. Doesn't collapse it. Protects the alveolar surface. Begins to produce around 20 to 25 weeks of development by type 2 pneumocytes. You understand? Now, this is a good question they can ask you at during your test. They can say at. They can say at what? Oh, they could say when. When does type 2 pneumocytes develop? And the answer is, you understand, is 24 to 25 weeks or 26 weeks, whatever you prefer. But is it that stage? And what stage is that? You remember, is the Canelo, the stage that I can't say, but we can go back and try to pronounce it. Canelicular stage. Anyway, that's the stage. It is composed primarily of phospholipids and a small amount of protein type SPA, SPB, and CSP. Okay, so here they're explaining to you what is the surfactant. What is it that keeps? So they're saying it's type 2 pneumocytes composed primarily of phospholipids. Most of it has phospholipids, a small amount of protein, and has a small amount of protein and a trace of carbohydrates, and also a trace of carbohydrates. So this surfactant has primarily composed of phospholipids. That's all it is. It's phospholipids with a lot of protein and a little bit of carbohydrates. It is mixed up, and that's what they call surfactant. So that's very important to understand what is surfactant, what is it made of. So it is just, the primary thing is phospholipids, and it has carbohydrates, and it also has some protein. Early research in pulmonary surfactants centered on the phospholipid components, mainly phospholipid. Anyway, this is all biology stuff, but this can come up in a test. Okay, and the amount of these phospholipids, the LS ratio and PG concentration, provides a predictive index of the lung prematurity in infants before birth and the risk for the development of respiratory distress. This is very, very, very important here. So they're saying that there's a ratio where they can determine before the baby is born if they will develop respiratory distress or not based on surfactant level. They have what's called the LS ratio, which is this here. Wait, where did it go? Lysertern and spheno something. This is based on mainly phospholipid, is called phosphatidylcholine, anyway, you guys are smart. You can read this and understand it. But the main point is there's an LS ratio. This is this 2 words here. And this amount is phospholipids. They can take it out from the mother belly while the baby's still in there. And based on the LS ratio, they can see if the baby can survive, if his lungs are mature enough, developed enough, or not. So if the ratio, there's a number to it. So if we keep reading, as LS ratio of 2 or more indicates a relatively low risk for development of respiratory distress syndrome, whereas LS ratio less than 1.5 is associated with high risk. So there's a ratio which is called LS ratio. So this ratio, if it's more than 2, a number is greater than 2, the lung is mature. Okay, so, but if it's less than 1.5, there's a greater risk of respiratory distress. Okay, mature lung, ML, which is mature lung, 2 is good, less than 1.5 is bad, respiratory distress. Okay, let's continue. Okay, so now we understand that it is possible to determine if the infant was born, if they're going to have respiratory distress at birth or not. And how can we determine that? We can determine it based on an LS ratio. And this SL ratio is a surfactant. Surfactant is made up of phospholipids, carbohydrates, and some protein. So if they can determine what is the ratio, they can tell you if the patient is going to have respiratory distress or not based on this ratio. If it's above 2, they are okay. They will not have respiratory distress syndrome. If it's below 2, they will have that. That is a very important finding in medical, is to understand if before they are born, if they're going to have respiratory distress syndrome or not. And it's based on what? It is based on surfactant. Remember, and surfactant is produced in the canalicular stage and is produced by which cell that we said? It is produced by type 2 cell. So this is a very interesting finding. So let's keep on going. Surfactant synthesis is regulated by numerous hormones, gene factors, including glycocorticoids, glycocorticosteroids production increase at the end of gestation, and stimulus receptors and type 2 pneumocytes increase in surfactant production, improving the LS ratio. Excellent. Okay, let's keep on going. And I have beaten you guys with a lot of information today. And the video is almost over an hour. And we will stop here and we will continue in part 3. And you know what? We only have transition from urinary. We can go up to here. So let's continue. Okay. Now we have said we have the LS ratio and we have many things. Okay. The distinctive function of developing lung is the formulation of relatively large amounts of fetal lung fluid that passes into amniotic fluid. Okay, let's stop here because I cannot focus anymore. Okay, thank you very much for watching. We will continue our learning process, and I want to thank everyone that is listening, and I hope you succeed in this learning process going through respiratory. It is easy to understand, but it's a lot of details. You will be at one point overwhelmed, but you're gonna make it, and I have good hope for you all. And I am learning at the same time as you are, and based on just me reading, and this is how I studied when I was in school. Thank you very much for watching.